Hey guys. As you can see with the background, I've been messing around with the green screen and have a new camera set up, so let me know if you like it or not, or it's kind of distracting. Hey, Daniel, Johnny, Hoya, Dirty, Dammy, Brad, yes, sir. It should be illegal to have such a cool name. Yeah, I was gonna say, I didn't even realize it until I started saying that. What does Hoya sell? I think everyone's gonna want to know. So I have one board, one project to review, but I'll wait a little while. So if anyone has any questions or anything beforehand, just let me know. Hey, Matten, John, Heed, as Bjorn. I should know that. I've been watching a lot of and reading a lot of Anglo-Saxon and Danish stuff lately. I'll ship them on Tuesday. So what do you sell? You never answered what you sold. Hi. How does it feel to hit 10K? Amazing. I don't know. I mean, everyone always says, like, you never expected to get to a certain point on YouTube, and I guess it's the same, except most people, I guess, when they started doing YouTube, they had a goal to, like, get fairly popular. I never really did. This was always just kind of a side thing for, like, work stuff, maybe get some views, just throw it with like some of the blog posts. So the fact that it actually has grown like this is pretty wild. Now it's just like, yeah, it's pretty crazy. I never would have thought it. So definitely appreciate it. And the Discord, I would say, is honestly more, maybe not more surprising, but I think more rewarding. Like the fact that I just saw it's now over 500 members. I think that's even cooler. Not that the YouTube side isn't as well. They both are. Hi, greetings from Hamburg. How's it going, Darius? Congrats with 10K, huge milestone. I know, right? Hoya says the coolest flux condensers. Google Tindy. Apparently, he seems to be pretty much a superstar around here. Alright, well, I guess I can um, start switching over to the first project that I'm going to review. It's from Ahid's project on the Discord. It's a Nixie clock, which, full disclosure, other than looking at it right here, I've really never looked at Nixie clocks or anything. I know that they're pretty cool when done, but I don't actually know really anything about them. So don't hold me to that side of it. Let me just switch this over. Alright, so his context for it is, so this is just a single board, so it has a single Nixie tube in it, and I guess just as a precursor, so Nixie tubes are high voltage bulbs that allow you to set what is displayed on the filament. So you can make really, really neat, like steampunk-ish, I guess, clocks or any type of displays with them. So his idea is just to power a single bulb with a shift register and have just a small PCB for that, and then have all of the driving circuitry on a separate board, so you don't have to have the expense and the mess of having a single full unit, and it gives you more flexibility, like where you put all of the bulbs. So I think that's a pretty neat approach. I don't know how most others actually do it. T Electronics YouTube, you loaded after 7 minutes. Won't help till you click it. Lovely. Didn't you have a tough time getting in here last time? But glad you made it at least. Nothing's really happened. So context multiple boards will be daisy chain, 6-digit clock. 100-volt line is derived from the 170 supply, which I talked to him about that earlier, so I can show what he's meaning by that. Both 3v3 and 170, same source supply. We'll use hot air or reflow for production. Won't have pick and place, hence no smaller than 0603. I will say 0603, if you can place those pretty well, there's not a huge difference between 0402s, at least in my experience. Goals, just for personal use, doesn't want it to destroy anything else, which is always a good idea. Want to make PCB smaller, so looking to optimize layout. All right, so first, before I go into any of his general questions, we'll just kind of give like an overview look of it. So J1, he has coming in with his power. So he has high voltage power, which is 170 volts DC, and ground for the high voltage ground, and then 2 sense lines that he'll use for the sensing circuit outside. And the 100-volt line, so all that is a voltage divider on the other board derived from that 170 volts. And the big thing with this is his 3v3 volts, which has a separate ground, even though he's labeling them as high voltage ground and just standard ground, off board, they are all tied to the same potential. So anything keeping them separate on here, they're still tied together back at the original source. So there's actually no isolation between the two, which is pretty important. So he has high voltage power coming in, current limited. Why are you using 2 in parallel instead of just a single resistor? You normally can do that because the resistance increases as they heat up, but just kind of curious. And then a current sense resistor, which takes the sense high and sense low, then goes to the Nixie tube. And then this is just a standard shift register that can turn on and off all of the drivers over here, which then sync current from the Nixie tube. And then I guess he had said you need to have pull-ups on all of the digits. No experience there. Bomb reduction. Gotcha. Yes, that's always helpful. So, I noticed a typo. The emitter resistors is to make the transistors constant current sinks. Which resistor? These resistors? I believe so. But if that's the case, wouldn't you need them? I don't know how this is laid out on here. Which ones are the sink and source on here? But either way. So this just syncs sources current from the Nixie tubes. These pull it up, and he has the shift register here with series resistors, label E1 to E3. Yeah, that's fine. And then he has series resistors here, which helps bring down the rise time. What what grid did you use, or am I on a bad grid? No. What grid did you use? I have no idea. You used a really small grid. Yeah, you used, what is that? A 0.25 grid, so you never change the grid on a schematic. You can do it on the PCB, but the grid on here always needs to stay the same. First look on here, again, logistics of how a Nixie tube works and whatnot, I honestly don't really know. So as long as logically that's all good, I don't see any issues. Here, if you're trying to reduce bomb count, I would get rid of the 0.1 mic and just have 1 mics for both of these. No big deal. For must have hit a magic button, yeah, right. For the connector coming in here, you could probably have some sort of filtering on these pins depending on how far they're going, just because these are coming in off the board and go straight to an unprotected shift register, so that's always a little scary. But I mean, that's kind of up to you. You're not selling it, just using it for your own use. I don't see a big deal. Same with some capacitance here. Otherwise, it looks fine. Obviously, this stuff overlapping, you want to not do that. Make it readable. I also will usually hide these just because it's kind of a... Why can't I move J1? There we go. Just because it makes it a little more readable, but no big deal. And then you have a net tie for the high voltage ground and ground, which regardless of what you decide to do with the ground setup, I really don't like net ties. There's very rarely any circumstances where they work well. I guess the one exception is if you do a really good job of separating like an analog and a digital ground, you can join the two grounds underneath your analog IC, but even then you're usually going to be better off just keeping them tied together. Okay, so now for the PCB, I just downloaded this new nightly build this morning, like an hour ago, rather. Fab, I'll keep courtyards, and we can get rid of silk. I guess we'll keep it. So, why do I not have... There, that was weird. So he had said that the traces are all just temporary for now. So any of the clearances or any of the really, really bad pad entries are fine. I'm not going to look at that. I guess I can look now at his questions. Is the overall layout acceptable, or do I have something seriously wrong that needs fixing? I'm not talking about details. I'll be redoing the tracks. Based on looking at it now and when I looked at it earlier today, I definitely don't see anything like egregious. It looks really nice. As for cleaning it up and making it smaller, without going to a double-sided PCB, which you're obviously trying to avoid, you can certainly condense these together, but without changing it being rectangular, I don't really see anything that's going to be major, that's going to make a major difference. Obviously, switching it to double-sided is a significant change, because then you can put this right here and then double lay them up, so you can probably cut it off to about here. But obviously that makes assembly, doing it by hand, a pain. One thing I haven't really seen before, I like the way you did all these separate. I always just overlap them. And now, especially since you can tie each of these on different layers, I always will just do that. But it kind of looks nice how you can see them all separate. But yeah, nothing really sticks out at me. And you had mentioned when we were talking earlier, you use different size vias. Congrats on 10K. Oh, thank you very much. You had used different size vias for the power side, which I don't know which you're talking about. They all look 0.3, 0.6. I'm not seeing which are different. But either way, unless you're going with a ton of power, way more than this uses, I normally don't bother. You can certainly do it, and people do it all the time. I really don't see a huge need. If instead, what I like to do is, so like, let's say this is a high power trace, I much rather put multiple vias on the trace to lower the impedance rather than trying to do a bigger one. But either way, it doesn't matter. Is it acceptable for 170 volts and 3v3 converters to share the same source supply, or should they have separate isolated supplies like wall wart and USB supply? Well, that is going to be a big implementation thing, because obviously you would rather not have to give this thing two separate supplies. And since you're dealing with all DC, I don't see a big issue of them sharing it downstream or upstream over here that goes to this. The biggest issue is, should the grounds on here share the same supply, or should the high voltage ground and your 3v3 ground share the same ground plane? And to answer that one, I honestly don't know. I think you can probably get away with it both ways. What my first inclination is definitely your idea of keeping the high voltage side on a single layer on the bottom side. I totally agree with that, and I would do that. As for if you tie the high voltage ground to the 3v3 ground, my rule of thumb for the most part is always yes, you should. But in this case, I think what maybe might make sense is if you can just block off all of this area and have a keep out to where you don't have any copper on that bottom layer, and just separately route your high voltage ground to wherever you need to on here. And then you're essentially keeping all of that high voltage separate, so it makes your creepage and clearances a lot easier to follow. But I think you could go either way, and I think you could make it work. If you do what I just said, then there's still the issue of, do you tie the high voltage ground to the 3v3 ground, which are on your other pores? Which my first guess or my first assumption would have been yes. But now that I know that they are tied on the power board, you could definitely have some ground loops over here. So I don't know, maybe, and to go back against what I said, if you're going to use that ground tie, what I might do is put it like right next to here and have it to where you can cut the traces and keep it separated, see if you have any issues, and then if you do, you can tie it back to the digital ground right off the bat. It's just, you're in a really weird situation. It's rare that you have the grounds tied together on another board and then are going to a separate board. Normally you would keep them together on the separate board and just route over a single ground, and then have the two different voltages with respect to that single ground. And there, at least you eliminate ground loops. So maybe that's another thought, if you have the ability to change this converter board, which I believe you do. So yeah, I know that wasn't a super great answer, but this type of stuff, I think anything will work. The next question is stack up. Currently, I have signal, ground. Here, I'll show it on here. I'm not going to do it justice just reading it. So signal top layer, signal, ground, high voltage signal. Now that I do not like at all, because your signal now can only reference this return. So I really don't like that stack up. I would be inclined to just do it kind of like a standard, like signal, ground, and then high voltage signal. And I think you should have plenty of routing space, because if you do my idea and do a keep out in this general area on the bottom layer for your high voltage, that doesn't affect anything else. So everything on your layer 1 would just get moved to the bottom layer or on the top. And I don't think that affects anything at all. Maybe over here, but just jump those to the top layer. So I think that would work, and I would certainly rather have that stack up than what you have now, but easy enough to change. Connectors switch to 1.27 to save space, but can't use those directly for high voltage due to clearance, hence current 2.54. Can I use multiple 2-pin 1.27 connectors spaced out? That's totally up to you. I mean, I think it's a little annoying having two different pitch connectors on here, but a lot of people like to do that so you can't connect them incorrectly. But I don't know, it's up to you. Separating these out for the high voltage side, I think that makes sense, but if I were you, how many pins are on here? 6, and how many are here? 5. So do you have space? Yeah, I mean, you could probably fit the same connector over here. But either way, that's kind of personal preference on that. Can you explain what is a net tie and its usage? So basically all a net tie is, and again, as a rule of thumb, just don't use them. They tend to make things worse unless it's a very specific situation. So if you have, let me try to pull up an example. So if you have a single PCB that has a split ground plane right here, so you have a connection of two planes. So say here they're calling red is analog ground, green is digital ground. You want them to be connected, but only at a single point. You use a net tie so you can specify exactly where those are. But again, as a rule of thumb, you're better off having these tied together everywhere. If you route a board correctly, if it's a mixed signal design, you can have them tied together or separate. But if you do it correctly, you're going to be better off with them tied together anyway. But yeah, that's what they're used for. So does that cover pretty much everything? Does anyone else have any questions or anything with this? I know the biggest question you had was with the tying the grounds, but I guess since you control the other board, my gut would be tie them together here, which they already are, and then send over a single ground with your 3v3 and 170, and then you eliminate your issues of ground loops, and then as long as you... So then I guess that kind of makes it tough with how you route your grounds over here. No, it shouldn't, because you only have your single high voltage trace. So as long as you have your clearances and creepage from this to your surrounding ground plane, or if you do a split there, if you do a keep out, I think that works. What are the currents? Will the trace width suffice? I have no idea what the currents are, but he said that this is just like temporary traces. So the assumption is he's going to reroute all of this with the correct trace size. So I'm not going to look into that. But yeah, these Nixie clocks, they're pretty cool. I'd always heard of them and I'd seen them online, but I honestly had never really looked at them. High voltage should be 5 milliamps per digit, for the most part a single digit at one time. Yeah, so I think we're going to be fine with current there. But yeah, super interesting board, and this is pretty much, from what he was saying, one of his first full from start to finish schematics and layouts. Definitely a pretty ambitious high voltage one to start with, but definitely a good job overall. Nothing egregious. You'll find out when you assemble it though. That's when you always find out. So yeah, let me know any other questions with this board, or does anyone have any other questions or any schematic or project or anything they want me to look at or anything. I don't have much of a plan for this stream other than going over this board, which now that that's pretty much done, I'm pretty open. Proof is always in the pudding, that is true. You are welcome. But yeah, definitely I like this idea. I might do that. Except I would probably have to have them evenly spaced out, not like everyone's spacing slightly different. Where can I share design to look at? Are you in the Discord channel? That might be the easiest, I think. If not, if it's on GitHub, share me just post the GitHub link. Is it putting or putting? Pudding or putting? I would think pudding, but actually that's one of those sayings like that has no sense of like where it comes from for me. Like bone apple tea. Also, do you have some knowledge about OBD? No. I had talked to someone we were gonna do a job for a while with it, but no, I've never touched anything with it. There's a lot of like open source stuff out there with it nowadays, I believe. Like, I think even doesn't Bark Fun or Adafruit, one of them I thought had something with it. Yeah, they do. Would you be down to look at an Altium project I worked on a while ago? I don't have Altium on this computer, but I can do the Altium viewer. So yeah, that works. Again, you're gonna have to have a way to get it to me either on GitHub or if you're on Discord. Oh yeah, definitely. If you guys haven't already joined the Discord, it's in the links in the description as always. And also, if you're not a patron, my Patreon link is also in the description. That is much appreciated. You mentioned protection of the serial lines on the board. Was that series resistors or more like TVS? So like I told you earlier today, series resistors are the greatest thing ever. They protect from over voltage, they protect from over current, they protect from literally everything. So really, as another rule of thumb, any type of line that you can get away with, and this includes like power lines, any line that you can get away with having a series resistor on is good. You never don't want to have that, but a lot of times you can't. So as for what you would put on there, it's up to you. I would certainly do a TVS just because on something low speed like that, it's not going to affect anything. If you don't want to add the bomb part, then yeah, just a series resistor. But you can never go wrong. Series resistor and TVS, that's solid. And you can put the TVS on the outward side, so facing the outside world, and then the TVS on the inside part of the board. So the series resistor will limit the current into the TVS diode. I had a PCB manufacturer halt fabrication and write me back asking why my ground flood fill was bigger than the PCB itself. That seems pretty crazy that they wouldn't know how to look at a Gerber. That's funny. Daniel CAN bus basically. Oh yeah, the OBD. Yeah, I mean it's just serial like stuff, but I've just never messed with it. What do you like to protect a line that has a pull up like I squared C? Pull up really doesn't affect anything. You can do the same thing. The big thing with I squared C and any higher speed line is you just have to be really careful with the capacitance that's on it. So you have to use like a low capacitance TVS diode for like anything faster than like USB and up. And that's another way you can protect a line. A heat is on that outbound line. You can put a uh, capacitor going to ground. But I usually just like having a series resistor in TVS. Johnny, how did you generate the Gerbers at Super Ed? Yeah, I honestly I've never heard of that. I mean, I guess if the Gerber actually created it bigger than the outside of the board, a logical question for the fab would have just been, hey, do you want like some shrinkage from the edge of the board? But for them to be completely confused about it, that seems kind of asinine to me. And I just saw a couple people join um, Discord. If you are one of them who wanted to share me a project, I guess just post it in the YouTube videos. Gia, no bugger, just woke up on the sofa. Major congrats on the 10K. Give it a couple weeks. Oh, 100K in a couple weeks. Man, I wish. That'd be nice. If a power supply has a higher voltage, tens of kilovolts output than mains voltage, would it make sense to use such a thing like an optocoupler? Can I wire the feedback directly to the IC? I have no idea. I've never dealt with something like that. I would assume you would want that to be pretty isolated just because anytime it can get across there, that's going to fry everything you have. Just like for safety, even just with mains, you want to have a separation between neutral and ground. That's why they're only tied back at the service panel. Daniel, we doing projects all night? I don't know about all night. I mean, technically, it's still kind of early here. It's super late for you. Or what? What time is it for you guys? Like midnight, 1 a.m. ish, something? I generated the Gerbers exactly the way the same I always do. Just send them to another PCB fab. Yeah, that's what I would do. That just kind of shows some lack of confidence in on their end, or at least just not understanding. Um, but yeah, totally, I would think understandable just to ask how much pullback. That's what I was trying to think of, not clearance. Pullback from the edge. Anything else seems a little excessive. 30 in Israel. Yeah, it's funny. It's super late for like a lot of the people who do the live streams in Discord, except they're the ones who like it this late. So it is what everyone prefers. Me, I would be long in bed at that time. I go to bed super early. Central European time. I don't know if this is the right place to post, but I would love some opinions on it. Okay, so Flavio just posted a project on Discord. Generative picture hardware. So I can try this. Oh, what's up, Gary? How's it going? Yeah, and most people are probably thinking, oh, you must be at like some crazy time zone where it's like early in the morning. Not quite. Okay, I'm just extracting this. And I have no idea what this generative picture hardware project is. To be honest, weekday would work best for me at this time. Weekends are the busiest. Yeah, I can imagine. Oh, it opened that up. Did you get to use KiCad along with FreeCAD? No, I don't use FreeCAD. I used to use SolidWorks, and now I use just Fusion. But for any mechanical designs, we have Emmy who uses SolidWorks. Did you just post my project on YouTube videos as well? Okay, sweet. The project is basically an ESP32 driving an e-paper display. You a victim of beer-induced drooling sleep as well? I'll let him answer that one. Okay. Okay, we got a little more complexity here. So, ESP32. Oh, I want to see how he's planning on programming this. Yeah, so he has the... oh boy, going through puberty again. He has the auto programmer also. I'm using an external driving circuit for the e-paper, so it's basically just the microcontroller and a battery charging circuit. Random question, how do you manage multiple board revisions with KiCad? In other programs, I just save a copy to increment a counter on the end of the file name. I use GitHub. It doesn't do it in a super logical manner, but if you do commits after like major changes, it's pretty easy to track it, and then you can do like a new tag or a branch at each release version. There is an online GitHub or Git visual editor with KiCad. I don't like it at all. It was utterly useless for me. It was super buggy, super slow. It wouldn't really open stuff. But I guess some people like it. So ESP32 boot. I've never seen a 100 nanofarad cap on the IO0 line. That's normally just on the enable pin. Decoupling. You can look at using CAD Lab. Yes, CAD Lab's what I'm talking about. Do not recommend that. And I actually tried it fairly recent, and it used to be like kind of a cheaper open source thing. Now he's gone all like commercial on it, and it's super expensive. So I did like the trial, or maybe signed up for a month or something, but no, I was not a fan. Power, so USB drives, battery, diode to prevent backfeeding. This is the protection IC, no, regulator. Enable drops it down to 3v3. So I don't know what battery voltage is coming in. That's his connector, battery charging, output battery, status. Need to have decoupling on the 5 volt, even if it's, I don't know, maybe you're assuming, oh yeah, no capacitance here. They do have a limit of like 10 mics on USB, but you want to utilize all of that, especially on the battery charger. Battery protection comes in. You've got the limiter for here. And, oh, I'm pretty sure I used this exact part one time. If it is the one I'm thinking of, I had to stop using it because the footprint was an absolute nightmare, and I couldn't actually really get it assembled. Hopefully it's a different one. Yes, completely different. Ignore that. The one I used was like 0.1 millimeter or 0.2 millimeters thick, and you like broke it just by placing it. Battery, single cell lipo, so okay, so you're keeping it at 3v3 there, that makes sense. Battery protection, so this, depending on what specific part number, make sure you're super specific. Oh, perfect, got that, because it depends on the cutout and everything here. And then you've got the voltage sense. You should have the voltage sense. It's been a while since I've used this one. Even though I graduated 4 years ago, I still have my student email from university. Free unlimited Autodesk credits. Yeah, I have a university email too, but I don't use those. JTAG connector. Don't know why you're using a JTAG. Then why do you still have the auto program? So you are able to program over JTAG and over USB. I guess that's cool. USB here, 47 puff, 27's here. CC's pulled down 5.1K. Again, I would have some more capacitance over here. Why use JTAG when you can use USB? Yeah, that was my point. It seems just extra to have a USB to UART bridge here. JTAG is for debugging mainly. I mean, I guess to each their own. TVS diodes here. Yeah, I don't, other than the couple things I had mentioned, I don't see anything here. This all looks super good. Do you have a layout? Yes. Wow, that is a super big. Is a super big board for a small. Why is it so big? Is this for, it's a Raspberry Pi, so you need all this space? I am guessing so. What is this? JLC, JLC, JLC. I guess they like that. Oh, that's kind of a cool way to do labels. I know I've seen that in the past, but I always just use standard text. Is this 2 layers? Yes. Board fill. Oh, nice tree. I like that. I made it as big as I could, still get it cheap. Oh, so you made it to fit the display. Got it. Yep, makes sense. And definitely good usage. This is something I'm going to do a video on soon. The last like 2 or 3 design reviews, other than Aheed's and Discord, have been 2 layers where they just abuse the bottom layer for routing. So definitely good usage on keeping it to a minimum, only right here, which it doesn't look like you have much of another choice. This is very, very, very tedious, and fair play to you for doing that, but that's a pain in the butt. I don't think you're doing any. God, you did it on everything. Yeah, I don't want to know how long that took you. I mean, definitely it's better in every way than traces. It's just a little extra, I would say, I would say. But yes, the bigger your power traces, you lower the impedance on a 2-layer board, so definitely a great idea. Just a little overkill, I would guess. USB lines coming in. I don't know why you looped them around here, because these are gonna just tie straight. I mean, I get why you did it. You kept the pair width. I don't like that, how you did the pad entry. I would do something like that. Again, doesn't matter in the least, but just looks better. I always try to never have an acute angle into a pad. My grid's all messed up, but you get what I'm saying. JOC is for the JOC ID number. Got it. Did not know that. You can hide the order under the chip. JOC. Put text on paste layer. Why is it better than thick traces? So if you did thick traces that were the exact width, it's not. He didn't. He has this open area. He has open area here, so you really couldn't have thick traces there. And the more you can make this essentially a plane, you have a lower impedance all across your power. Does it matter for a lot of these cases? Probably not. And how does this even get power? Why am I not able to select this? There you go. The main area it helps is over your high speed IC. So like if there was a way to get all of this a power pour, which you obviously can't on a 2-layer board, that's where it really makes a difference. But yes, I would say that helps minimally, but it's nice that he did it. So this is something Aheed had asked a while ago just about tombstoning. So this is the type of unbalanced copper that could cause an issue, but he's using an 805, which doesn't matter how badly it's unbalanced, it will not tombstone. But if you're dealing with like 0201s or 0402s, you want to keep these a bit more balanced. Actually, Never mind, he has thermals on here. Ignore me. Those are fine. I forgot about that. But yeah, that if this was, say, all connected and this was just a single trace, that's when you start to worry about tombstoning. But no, I mean, this definitely, whoever's this was, Flavio, you certainly did a decent layout. I mean, I'm sure me or certainly Gary could nitpick this and find other stuff. Obviously, anybody's board you can if you look hard enough. But no, really, really good job. I don't see anything. And you kept the USB traces about as short as you could. Everything's balanced. This is a really big thing with not so much 2.0 USB, it doesn't matter, but with like 3.0, 3.1 Gen 2 stuff, you don't want to have uneven nodes off of here. So like you wouldn't want to have this over here or going in a different direction. Everything needs to be balanced, which you did. And I know this is probably all screwed up from where I messed with it. But yeah, well done. I don't see anything else that is even really worth mentioning. I guess just one last note for other people. The way that he did the second traces, the bottom layer traces, and immediately jumping back to the top, that's absolutely what you want to do on a 2-layer board. You want to do everything in your power to keep this bottom layer solid ground, which is what he did. Just because you have that second layer, don't start throwing crap on all over here. But yeah, well done. Can I share my design, or is there a queue? I believe there's just one person ahead. Okay, before that, I am gonna take a peek at Daniel's. This, I'm pretty sure there's not gonna be a whole lot here. He's kind of refined this quite a while, but anyone who's a patron gets priority. So let me open this up. Thanks, it was my first real layout with a microcontroller. It took some time, but thanks for the pointers. Yeah, for your first one, really, really well done. Pores are not that important. Yeah, I mean, if you have time, I mean, it certainly looks good and it's better. But yeah, I mean, I personally would not be spending the time. The only time I'm doing pores like that is when it's high power. Because anything to lower the impedance for high speed stuff, if you care about it that much, you're going to be doing at least a 4-layer board. So that's never something that comes up. Okay, so this is going to be quite an easy review. So this is Daniel's. It's like a 16 channel FET board for driving pretty high power loads. I don't know, Daniel, how much does each one of these draw like 4 or 5 amps, I think. So he has manual overrides and driving from I2C, which then goes from a CAN transceiver is how he controls it off the board. And then the ESP32 is controlled with ESP Home. So it's like this whole integrated system. I'm really not even going to look at the schematic because everything on here is really good. He's driving them isolated current sense going to the FETs here, and then he has a separate sense circuit right here, I believe. Yeah, here, which senses the current. Max 15 amps. Yeah, so this is pretty beefy. Yeah, this thing's an absolute tank. So here's an example of when you no ESP Home. Isn't that what you were saying you did the over-the-air update with? I thought it was. Unexpected Maker. Hey everyone, how's it going? All my own code. Fair play. I like that. So now this, exactly what I was saying on the other board, this is when 100% of the time I would use a copper pore. you're driving up to 15 amps, yes, you could do a solid single trace, but you're not going to be able to gain as much spacing here. So having a pour lets you optimize the most, because a lot of times with stuff like this, and I guess here's something, Daniel, if you start having an issue with heat, you can do stuff like this and drag these pours down, because oh boy, it's such a big board, it takes a while to refill the zones. Because as long as you have the width to where it's not going to burn up the traces or get ridiculously hot, the way you optimize to keep these cool is just having extra copper. It acts like a heat sink. So oftentimes I've done stuff like this where traces look absolutely ridiculous and you build them up around just to add extra copper, but it certainly can help if it becomes an issue, that is. So we have our FET going down here, which then, what is this? Is that our sense resistor? Yes, our sense resistor with the Kelvin connects. And then 12 volt just passes in and out, and that's what senses it. Oh, max current per channel would have answered my own question. Do a pour on the bottom and vias as well. Yep, that makes sense. So the one thing, and I forget if we had talked about this a while ago. Actually, no, never mind. You're using pretty much the top layer for your main ground reference, so that should be fine. Because what I was thinking is he's doing exactly what I was saying in the previous layout not to do. Don't fill up your bottom layer on a 2-layer board with a ton of traces. But the top has a ton of free space here, and he's done a pretty good job of having most of these in separate sections, all horizontal and all vertical, and vice versa here. But certainly for EMI reasons, if this board were to be 4 layers and make the inner 2 ground, it would be better in every way. And you could also get a little extra heat dissipation. Is it worth it? I don't know. It would certainly be better, but it depends on what all is important. Otherwise, everything else. Oh, throwing the KiCad logo. I like it. Have the 120 ohm termination if it's at the end of the CAN bus. Very important, except when it's not, which in my experience it's normally not. Normally it's the shunt resistor that gets hot. Yeah, that tends to happen, but same thing. If the shunt resistor is hot, that means this port is by default hot. So if you extend this port, it gives you a little extra copper. But if it's not outrageously hot, it doesn't matter. Yeah, I'm just cheap. Yeah, that'll do it. Happy 10K subs. Thank you very much, Neil. Much appreciated. But everything else here, I doubt there's really gonna be that much. What is this? So, I mean, I guess the one just nitpick is 1206 capacitors are pretty massive for decoupling. I know it's probably just to make it easier hand soldering, but I think you can manage some smaller caps. But yeah, super neat routing. Oh yeah, the JLC thing. So apparently that's a thing. But yeah, I don't see anything else that sticks out. Again, like I said in the last one, I certainly could find some looking at this long enough, which is like with every board, but looks great. And then this is like the stuff I was saying on the other board. So he never has an acute angle going into a pad like this. It's all a perfect 90 degree. which used to cause acid traps and is why it's still considered a good idea to do it this way. But truth be told, acid traps don't matter anymore, so it's just for looks. Unexpected makers, horizontal and vertical ground on top and bottom, really that important? Ground via closer to decoupling would be more important. On a 2-layer board, no. A 2-layer board, your goal is over everything else, and is why, truth be told, this board is lacking in that. So let's say if this was a high-speed, let's say this was a high-speed signal, which none of these are, another reason why it's not the end of the world. If this was a real high-speed signal that goes across here, it goes across this cut. So your bottom ground layer, your return, if this is high speed, your return path wants to follow the path of lowest impedance. Doesn't matter the frequency, it's always the lowest impedance. On a low speed signal, that defaults to lowest resistance. On a high speed signal, it defaults to lowest inductance, which is directly under the trace. So if this was a super high speed signal, it has to jump around to find another path, and it'll constantly try to get under this. So you're going to have a really big, actually, Daniel, one big thing, you need stitching vias in a bad way. Yeah, good catch. I don't know if that's exactly what you were talking about, unexpected maker. But yes, without stitching vias, this would be a noise nightmare. But to unexpected maker, to your point, having vias right here to help it jump across, yes, that's good. But no, your best case scenario is to not have any cuts below. So by splitting horizontal and vertical, as long as you can get them to where you have a jump like this, that's the best scenario with traces on both sides. But your best case scenario is like the board that we just looked at. And this, I'm going to be doing a video here in a little bit. And Gary, a VN pad, okay, I'll check on that. So this board is a perfect example of how exactly to do a 2-layer board. So you have USB, it's perfectly referenced to the ground plane underneath it. So say if this was a high-speed trace, it jumps from here to there. The ground is directly under the trace at all times. Whenever you have a cut in that, like right here, if this was a high-speed signal, it now has to return around here, which is worst case scenario. If it's on low speed traces, it doesn't matter as much, but on high speed stuff, it's the most important thing. Right, but folks should not be losing two layers for high speed, but okay, I get what you're saying. They shouldn't, but they do. I mean, when price becomes a priority, you absolutely will see. I mean, even stuff as slow as USB or an SPI bus absolutely can fail EMI compliance, or buck converters. You see buck converters all the time on 2-layer boards, and if you don't filter and do a good layout on a 2-layer board there, you're not going to pass. I am not going to be able to know, Gary, where you were referencing that VN pad, but yeah, Daniel, apparently there is a VN pad somewhere. Gary, where was it on the board? Top connector. Got it. Good call. Yes, right here. Yeah, so that's a no-no. You can still assemble it fine, but paste is going to wick in there and be a nightmare. The only way you can truly do VN pads is if they're filled and plated, which is super expensive. But yeah, otherwise, add stitching vias to help avoid what we were talking about. And like with what I was saying with unexpected maker, definitely where you have jumps in the traces, add stitching vias super close to there to allow it to return around this. Because if not, you would have some massive ground loops here. But yeah, overall super good. And he's built, I think, 2 revisions, 3 revisions of this, so it works. He's just been fixing little stuff here and there. Okay, let me see. Which is the next one? I created this digitally controlled power supply, one of my first end projects, that if I recall correctly can take up to 4 amps at 12 volt input. No reason to do this besides my own learning. Afterwards, I realized how awful my decoupling bolt capacitance was. Okay, let me open this one up. So yeah, after this one, I do not have any others to look at. So if you have any other questions or any boards to review, certainly get them queued up. Oh, ADSEHGL, however you say your name. Oh, you zipped? Oh, you zipped a zip for that file. Got it. I thought there was nothing in there for a second. Yeah, next time just upload everything separate because when you download from GitHub, it zips it as is, so you had a zip within a zip. Oh, this is the one that's Altium. I am not going to be opening that in KiCad then. Yeah, agreed, Gary. Super, super clean looking. Where's the free viewer? Okay, here we go. Zipception, yeah, right. Oh, you have a lot of different versions on here. I thought you could now import Altium into KiCad. Can you? I have no idea. Oh. So it's not supporting that, it looks like. Maybe. Oh, okay. But I don't have anything else. Outstanding. Yeah, so maybe if this only opens one at a time and I have to upload each individual schematic, that's going to be a pain. So yeah, if anyone else has any projects or whoever uploaded this, if you just want to send some PDF outputs for the schematic, that's totally fine to look at. For the PCB layout, it's kind of a pain, but it's still doable. So yeah, but anyone else have any other boards or any general questions, whatnot? There is a PDF in that zip. So now you're telling me. Okay, let me check that. I see. Here is a question. When does signal be become a high-speed TM signal? I mean, it depends on who you ask, but real, like, crazy high speed isn't until you get into the gigahertz, but anything, like, faster than USB 3, so, like, what's that, 480 megahertz, that's when it really starts to matter. But for, like, EMI stuff, the buck converters and stuff will cause more stuff to fail than anything else. But it depends. Maybe Gary, what's your rule of thumb on when does high speed become high speed? Okay, so we have connector going to series resistors. I like that. Going to an STM32. Yes, and to Gary's point, technically frequency is irrelevant. It's 100% dependent on the rise time of the signal because the rise time is what actually causes the crazy harmonics. But typically, if you have a much higher speed signal, the rise times by default have to be faster, and depending on quasi-peak, peak average, how they're actually detected, there's going to be more of them, so it's going to have more power. But yes, the rise time is actually what matters in high speed. Goes to STM. Tons of decoupling here, separating that out. I have started putting all of my decoupling on the actual IC just because it makes it easier for placing. I think I saw that from Gary, actually. Data change rate is irrelevant. Yeah. Okay. Oh gosh. Humor me. Looking file import non-KiCad. I don't know, man. You be the guinea pig on that. I at least finally have this open. So now we have our buck, 300 nanofarads on the VIN, our inductor. Oh, it's a voltage sense. I was like, that's a weird looking converter. So yeah, we got our buck. It goes out. Yeah, you're really low on any sort of capacitance. Is he getting paid overtime for the stream? Yeah, I probably should. I don't know. College football started today, actually. I started watching. So hopefully, Gary, you got football on in the background. I think Hawaii plays tonight. I know obviously Nebraska was playing earlier. For the non-Americans who are watching football, I know soccer, actually. We call it soccer and football. But yeah, I don't know without seeing all the specs and what frequency this is. 4.7 nanohenry. You're way low on input and output caps. I'm surprised that this was stable at all. USB coming in, blocking cap, prevent backfeeding with a diode. Yeah, I'd fix the capacitance later on, and I don't have the diode by the inductor. Oh, so yeah, this was synchron. Yeah, that'll do that too. For your voltage sense, a more voltage sense MCP 41. That's a I square. Oh, digital pot. Go figure. And here's a bunch of other stuff I'm not going to get into. Now layout. Oh, that's all that you have in a picture. But yeah, big thing on the buck is obviously inductor or capacitance, super important. But schematics laid out really nice. I like it. Pretty logical, and I like the hierarchical sheet usages, of course. Okay, next one, Johnny posted in YouTube videos. ESP12 board. ESP12? What is an ESP12? Did I miss that in one of the releases? I thought it went from the 8266 to the ESP32. There was a 12 in there somewhere? Go figure. That's sad I don't know that considering how often we use them, the 32s. Oh, you only have Gerbers on here. ESP12 is an 8266. Got it. That would make sense then. Alright, so I'll open this in Fab 3000. Sorry it's taking so long. Next time when you post these, or if you post them to me, tell me what format they are. I know I should probably just look first, but still. Oh, it was an Eagle file. That would explain it. This is the name of the game with Fab 3000. Every time you do something, it freezes. Unfortunately. When it works pretty well. You also like ESP32 and dealing with Wi-Fi, need a fast micro? Oh, for sure. At the price, there's absolutely nothing else you can beat, in my opinion. Okay, got it open. That was painful. Okay. The big nuisance with looking at Gerbers to do, I've almost bought Fab 3000. Looks like such an amazing tool. No. It's not. Gerb tool is, or Cam 350 is so much better. Does Fab 3K work? Sure, but it's I mean like this is nonsense. It's super slow, but the biggest issue is if you do a DRC check, no joke, if it's a 4-layer board or up, if it's over 4 layers, it won't do it, but even a 4-layer board will take overnight, where Cam 350, a few minutes, 5-10 minutes. College football starts next week. Boise State, UCF. Yeah, that's gonna be awesome. Okay, so what was the problem with doing Gerbers is you can't disable the pores, so it is really a pain. Um, so yeah, what was your main question? Whoever uploaded this. Yeah, unexpected maker. We should do a collab one of these days. That'd be fun. Oh, you had asked, does the copper look fine for power? What current are you running? That's gonna matter quite a bit. Yeah, what current? And also, is this a 1 ounce? What's your copper thickness? 1 ounce or 2 ounce? Because that's pretty important. Oh, not Steam Cam 350. Thanks for checking it out. Curve view as potential. Yeah, I mean, KiCads is, I mean, it's just a viewer. The main reason you do, I mean, at least like us for assembly and fab is your GURB viewer has to be able to panelize, has to be able to do DRC or DFM. ideally handle IPC file formats, even though KiCad doesn't. Extract net list, do net extraction, net comparisons, stuff like that. LED strip 5 amps a channel, 1 ounce. So what's our thickness here? 3 millimeters for 5 amps. Yeah, that should be more than enough. Here, I'll actually, for once, I'll use one of KiCad's calculators. I always forget about them. Why is trace width? Oh, that's traces are on both sides. Got it. So technically, yeah, I mean you're at a derating of at least 1 even without the double stitching. So with the double stitching you can do 15 amps. So yeah, that would be totally fine. So I don't know if you were the one who mentioned earlier asking like why not traces over pores. If so, or even if it wasn't, so this is a great example. You did traces for this and pores for down here. Your traces work totally fine. There's no issue with that. It handles all the current you need. Could you have gotten more space with pores? Obviously. But if it handles what you need and it saves time, I mean, there's no reason not to. It's 10 levels beyond my requirements. You are the crazy one to do CHEM work. I'm just manufacturing my own products, so to do all that in my own EDA tool, yes, certainly. I completely agree there. As for the rest of your layout, I mean, it's pretty simple. I don't see much here. But again, like we were saying earlier, this is a which one? Here. This is a great example of doing a 2-layer board correctly. All the traces, top layer, he has only, other than the power, which nothing else really runs over those, only these 2 traces that have to go on the bottom layer, and he has vias to jump them super short, which is exactly what I would do. So here's again pads not entering at a off angle. If you can make them perfectly straight across, not that it matters in the least, but it looks better. But yeah, otherwise I don't. Oh, your keep out, I believe is wrong. You have to have like X millimeters on each side outside of just where the antenna is, though I've done plenty of boards like this and it works. But if you want it to be the standards, that's how it should be. Oh, got another review. This is my controller design for a prototype robotic prosthetic hand. Now that sounds cool. This is in KiCad. Fantastic. Alright, while that downloads, I'm going to go to the bathroom real fast. I'll be back in a second. All right, back. Let me see if it's, yep, done downloading. Yeah, I'm looking forward to this. It has some mistakes, but still worked fine. I don't know if that was Fab 3000 or not. What's wrong with dip trace? I honestly don't have a ton of experience with it. Never messed with it. I don't know what you're comparing it to, like compared to KiCad or what. And again, while I'm doing these, and especially in between, if you have any other, God, stupid headphones. If anyone has any questions, just throw them out here. Oh, for whoever posted the prosthetic, there's two projects in here, Bionic X and MCU. Which one is which? Which one do I open? Bathroom speedrun. I mean, I suppose. Literally, the bathroom is like right there, so that helps. I didn't know you could do emojis on YouTube streams. That's pretty cool. I will. It is Bionics. Okay, cool. Nice hierarchical sheet. I don't know why that's so hard for me to say. Okay, so power supply. So one thing I do not like about this is I like connectors. I like everything reading from left to right. So input connectors, this stuff, then output connectors. So didn't hear me flush. That's why the audio was off. Can't be hearing all that. But either way, that's preference. I just like the outputs all being on the right side and inputs on the left side. So power supply, we have 6 volts. See, that just gets kind of confusing. So we have our power coming in and then going out. He backed it up. Yeah, something like that. Battery goes to the power supply, status, voltage, VUSB. I guess there's a separate power for the VUSB. Oh, VUSB. See, this is why I like the connectors being separate. Like, there's a connector within a hierarchical sheet, which I really don't like because I like having everything that connects to the outside world visible. So as long as you're able to see it on one glance, because it gets kind of confusing, because now we know that that's a USB connector. Explained in GitHub. Alrighty. 5 servo motors, 1 for each finger, 2 servo motors with wrist gimbal onboard accelerometer, Nordic Bluetooth, 600 milliamp lithium ion charging, 3v3 1 amp buck boost for EMG sensor and the rest of the board, 6 volts at 4 amp boost for servos. I guess not everyone goes with a microphone, right? Congrats on 10K. Appreciate it. And hi, dudes. If you're using ESP32 together with another MCU as Wi-Fi expansion, are you using... why would you use another MCU? If you're just needing extra GPIO, use like just a I2C expander. I don't know why you would talk to another MCU. And then our IMU, which takes in 3v3, Bluetooth, which is obviously our Nordic. But really, even if I'm not a huge fan of some of the way you did the hierarchical sheets, really, really cleanly laid out. I like this a lot. And in here, super, super clean. This puts me to shame, and I'm pretty anal about mine. This is really well done. Got your Parasitic calculations for your C load. That's always nice. Again, where are you flashing? No idea. I like having the decoupling on here, just again, personal preference, programming interface. And I'm gonna do, I know I've been saying this a lot. I'm gonna be doing a video at some point on different value ceramics, but for now, that's kind of the norm. I would usually just have a bigger bulk cap that goes near these, but either way, that's fine. Got your antenna. Oh, you're doing that from bare bones. That'll be fun. Just obviously, I'm sure you know this. Since you have now a Bluetooth, does this have ESP32? No. Does it? STM, no. So this is your only RF. But since you're doing a custom antenna, for if you're going to sell this, you have to get certification, which is an absolute nightmare. I mean, if you have another MCU without Wi-Fi and want to use an ESP to update it, for example, oh boy, if you're actually doing OTA updates from another microcontroller from the from the ESP, that's a whole can of worms. Matt posting again. I guess you're pasting something. I don't know. But yeah, certifications as an intentional radiator, complete nightmare. I'm sure you know that, but just be aware. Unless you're doing massive numbers, it almost never makes sense. DC buck boost for MLCC using several values with different packages is not really required. Yes, that is what I have experienced and simulated, and just need to do some more testing. And I'm going to be doing some videos when I start the EMC series. Just a prototype, no intentions of selling. Fantastic. Buck boost, again, kind of like what I said with the other one. This is presumably what the bare minimum capacitance was input output. I would like to see a bit more here, depending on current and everything. 1 amp, you would probably need something. And if you don't have any other bulk capacitance, which it doesn't look like you do, you certainly will need to. I see you have some here on the output side of this, which is good. But if you don't have it anywhere else, that's going to be an issue when the input cap needs to get charged. Boost converter. This is really, I know I've said this a few times, but this is really well laid out. I like that a lot. I see 2 different grounds, which certainly scares me, depending on how you tied them together or did separate power pours, which we'll see when we get to the layout. Nothing jumps out at me here. Battery, charger, that all looks fine. It doesn't look like you have any onboard protection. Presumably you're using a pouch battery that has onboard protection, but I still always like to have one on board. But for a prototype, probably not that big of a deal. USB-C using just the 2.0 speed. CC's pulled down. That all looks fine. No TVS protection, so ESD could be an issue depending on what you're doing. Triple access accelerometer, not much here. Bluetooth, already looked at. MCU, place 1 cap, post each VDD pin. Ferrite, so this is yet again something I'm going to be doing. Oh, this is your analog supply, so that's better that it's just going here. Ferrites separating from your supply can be kind of sketchy because now you lose all your interplanar capacitance. The fact that it's on your analog side and not your digital, probably fine. Boot 0 with a switch, even though normally you never use the switch. Reset. I'm not using USB just in case. Makes sense. programming interface, RGB. That is a very, very, very fancy looking footprint. I like that. Everything else on here looks pretty standard. Oh, so this doesn't even have the power side. This just has like the MCU end. Got it. But yeah, I don't see anything that stands out. But yes, for sure, these going off the board, you need some serious bulk capacitance, or your voltage rail is gonna sag really bad, depending on how much of the how much transient current is on those connectors. You were even more anal than me, except you messed up that. There we go. You'll need to fix that now. Okay. Look at the layout. If there is a layout, I don't know. Okay. Keep out for our antenna. This is a 4-layer board. Top copper, ground power, bottom copper. So this is the older style 4-layer board. We still do it. That's like the Henriot style. Nowadays, the more modern is the ground, but you can make do either or. Higher speed stuff you'd like to have on the top layer to reference that ground rather than reference power, which it looks like that is what he did ish. These are really goofy sized vias. Yeah, you have a pretty small annular ring. So normally, depending on the fab, you'd want that to be 0.6 or 0.25. I know with PCBWay, going to 0.25 increases the cost a little bit. So maybe that's why you did it that way. They just look kind of funny because of the sizing. So yeah, for sure, I would have you built this? Because I would be a little worried that this board's not going to work without some sort of electrolytics here. I would assume you would want probably one for each servo, just because. What in the world are those? Dang, those are your. So potential issue here too. Oh, 6 volts. Never mind. Never mind. I bet you're fine. But just watch with this what the DC bias is. These are not going to be 47 mics. It could cut it at least in half. It's in the photo D folder. I don't. Make sure when you're referencing something I said, make sure you say what you're referring to, because there's such a delay. I don't really know what you were meaning. The EMG signal, is it already amplified? I have no idea how an EMG signal works. No, it goes straight into the micro. 3D viewer. Let's see if all the parts are on here. I am guessing they are with how long it's taking. Oh, that is super cool looking. God, they really have gotten better with the new KiCad Nightlies, even from like a month ago. This looks amazing. And this isn't even with ray tracing on, right? I also use ground power on 4-layer boards as much as more multi-rail, but the ground stack up. Is it signals on the bottom and power on top, or mixed? So it would be signal power on top, ground, signal power on bottom. And the reason is it's twofold. One, you guarantee that every one of your signal has an adjacent ground reference plane without ever having to worry about it. The second is wherever you put power on, if it's the top or the bottom layer, you have super close spacing between the ground, so you get better interplanar capacitance. The issue, yeah, this is crazy how good this looks. And I'm liking what you and the other board I looked at did with the negative silk screen. Yours is a little different, but I really like the look of that. I might start doing that. So another issue with this power ground is, since you have So you have prepreg in between the layer 1 and 2 and 3 and 4, but you have the fiberglass core in between the inner 1 and inner 2. So you have a much bigger spacing, so your capacitance isn't as great. So that's an issue with this stack up. Is your ECG signal preamplified? Oh, you're asking him specifically. Yeah, that's a better person to ask. So now you're split planes. So you have 3v3. I don't care about your power. So what is split here? I don't know why did you put a split here? They're both the same. They're both the same nets on either side, aren't they? They're both ground. Yeah, it's all ground. I don't know why those splits are there. Oh, photo is in the... Got it. Okay, yes. I'll certainly pull it up. That'll be really cool. Oh, that's awesome. Who built that? That's a really cool matte finish. Yeah, what fab did you use for that? I'd be curious. I tried to separate power ground from digital ground, but they're connected. Unless I'm completely missing something here. Both of these pores are ground. You just tried doing a split because I remember you have the two grounds here. Oh, they are all tied together. Got it. Okay. Yeah, again, in my opinion, there's too many risks of splitting it like this. I would have it all tied together. If done right, you can keep them separated like this. But as long as none of your signals are crossing or none of your sensitive signals are going over your digital lines or vice versa, the return currents aren't going to be there anyway. So the split does absolutely nothing. So like at its best, the split doesn't hurt. At its worst, and you do cross a plane or you force a path where it doesn't want to go, you make it way worse. So that's why I tend to not do it. But yeah, otherwise I don't see anything here. It looks really good. Yeah, it was a stupid way to do it. Yeah, but if it worked, it worked. And that's sometimes all that matters, especially with a board. Like, once you throw the antenna on, you're screwed actually, production-wise anyway, so as long as it works. Gotta run. Congrats for 10K and thanks for the stream. Thanks for tuning in. I'll see you on the next one. I'm not doing such things on my current design. Perfect. So yeah, did anyone else post anything for review? Not that I know of. Again, if anyone has any designs to look at or any questions, just let me know. For designs, people have just been going on and posting on Discord for me, which of course, if you have not joined Discord, you must join. Over 500 members now, which is, like I was saying earlier, that's honestly crazier than the YouTube subscribers, in my opinion, just because I never would have thought it would have been even close to that. Hang on one second. I'm just going through the Patreon to see if anyone else from there had any. And yes, if you also have not joined Patreon, the link for both Discord and Patreon are in the description. Want to try showing how to make those beat neat labels? Yeah, I don't know about that. That'd be ugly. Unexpected Maker just wanted to say it's super generous of you to be reviewing people's designs. Anytime. I find it pretty fun. I love doing these streams. Like I've said a few times, honestly, like doing the designs on stream and even like this stuff, I like a lot more than doing the videos themselves just because dang, 0201, good for you. Um just cuz the editing on videos gets really tedious. So just being able to do these as is pretty nice. Kyle is awesome. Yes, that is true. I agree. Back in the days, it was all arcs and lines, but now you Kai buzzard. So I guess that's the way you do this stuff. Oh yeah, because that's all like separately drawn. That's pretty cool. But yeah, anyone else? Any designs? Any questions? If not, I was planning on streaming till 7 or 7 for my time, so 18 more minutes. But if no one else has anything, I guess we can always wrap up. Hey Kyle, I'm having a great time on these streams. How do you choose the via's diameter? Honestly, and this I was mentioning a little earlier, even if it's high power stuff, I'll normally stick either 0.255 or 0.36. If you use like JLC or at least PCB way, this is standard. If you go to 0.25, you have to pay extra, and it's kind of a surprising amount. If you do the zero point 0.3, zero point 0.6, that's fine. If you're doing real high power stuff, sometimes it makes sense to go bigger, but I much rather do like this approach and have a bunch of them because they also help for dissipating heat too because it gives you some extra surface area. But either way, always use 0.63. Yeah, exactly. Time to up my labels game. Yeah, right. That's what I'm saying. These look really good. But yeah, I'll give it a couple more minutes. If no one else has anything, we can wrap it up. And then definitely either way, let me know. For streams coming up, I honestly don't have much planned. I've got some videos coming up. I'm gonna be out of town next week. So hopefully we'll be able to still get a video up next weekend. Just having it like pre-made, but no promises. So streaming, I won't be back for a couple weeks, but I don't really have any ideas for streams. So let me know for what you would like on that. I'm gonna try to keep them kind of separate from the main YouTube videos, but whatever people like. Any tips on using vias when you need 5 amps to the bottom, big vias? Yeah, I would do this. I like this way more than I do bigger vias. So I would do exactly like this. And there's calculators you can use online for how much current you can put through a via, but like this, you're not going to have an issue with how much current can go through it. Gary Oregon trip, yes, that's gonna be next Wednesday. Looking forward to it. Tented or non-tented. So what I do is if it's a first batch prototype, I do not tent them just because it's easier to rework. But you really, really, really have to be careful when you don't tent them. And this has bitten me before. Sometimes if you do, oh, via and pad, not good. If you have like a via, I'm trying to find an example. Like say if you had a via like right here or something and it was connecting with a trace and you don't tent them, you can get solder to short across there and it's a really big pain. So definitely that's a big gotcha if you don't tent them, but then for production, I'll always tent them. Great streams. Thanks a lot. I've learned a lot. You are great. Very flattering. I appreciate the words. What size vias would you use for power? I would use 0.3, 0.6, just like this, or 0.3, 0.6. What about a through hole and fill with solder? Yeah, I've seen that before. Didn't you say the vias should be between the pads? Does it not matter for the 6K bolt capacitors there? Yes. Yes, good point. What Ahid's saying is to lower the loop in here, ideally the ground vias should be on the inside here, which makes the loop area smaller. So yes, I would say that would be better. Honestly, using these massive ceramics, I don't know how that goes with these bucks. I've never done that. I'll never go above like 22 mic, and I still will have a electrolytic, where ESR and ESL on those is always going to be a lot more than ceramics. But yes, I would definitely, and especially for like decoupling, you want to have the vias tight. Oh, I guess that's a note I have for this board. There's no stitching vias really, and you don't have any vias for all of your caps here. So for sure that's an issue, because you need to have it be getting ground from somewhere other than this. So I would stick some vias here. Suggestion: more basic tutorials of, say, building blocks with your hands-on rules of thumb thrown in. Okay, give some examples of like any like suggestions of what, like vias or just anything like that, because I've been thinking about that too, but it's just kind of hard to come up with the actual specific topic. Tenting, covering with solder mask. Yep. Like T-electronics, fill with solder. So Daniel, yes, so that's like a plugged in capped via. I had mentioned this earlier. I'll see if I can pull up like a chart of the different kinds. So yeah, here. So this is tented. This is what sometimes happens if the tent is too big or the diameter is too big, and then there's not tented. And then you can do plugged. So they'll plug it with conductive epoxy and then cap it. And that's really the only way you can do a via and pad, because then you don't, like right here. So then you can put a via within a pad or on a BGA right on the ball. And then you can also get real crazy with blind and buried vias. But that gets super, super expensive. Hopefully one day that'll come down in price. Yeah, I was thinking plugged, not tented. Yep, makes sense. Alright, well then I think can wrap up this stream. So yeah, like I said, probably 2 weeks until my next stream. I'm hoping to have a video out in a week from today. We'll see. And definitely let me know any suggestions for streams or videos. And I hope that this format, kind of not having any sort of plan or schedule, was helpful to people. But yeah, I appreciate everyone for tuning in. Once again, Discord, Patreon links are in the description. And I will see everybody in the next video or stream. Have a good one, guys.